Now in this lecture, we are going to look at time and space complexity of breadth-first search algorithm for single source short path problem. So here the pseudocode of our algorithm over here. So based on this pseudocode, we are going to identify the time and space complexity. So as always, we are going to start from the first line of code. So in the first line, we are creating a queue. So we know that creating a queue based on the linked list that we created in our previous lecture takes O1 time complexity. Then the next line of code is we are enqueuing any starting vertex to this queue over here. So when we are enqueuing any starting vertex to this queue over here, it will take O1 time complexity. Then we have a loop over here in which we are checking that if queue is not empty. So this means that in case of graph, we are going to enqueue all nodes that we have in our graph to this queue. So this means that this queue will run O number of nodes. So if the number of nodes is V, so the time complexity for this queue will be OV. Then in the next line inside of this loop over here, we are dequeuing the elements. So in case of linked list implementation of queue, when we are dequeuing elements, the time complexity is O1. Then we are checking that if this dequeued element is visited or not. So if it is unvisited, we are going to do this operation over here. So in this case, this if condition will take O1 time complexity. Then we are going to mark it as visited. So updating the property of the visited will take O1 time complexity. Then we are going to enqueue all adjacent unvisited vertices of the P to this queue over here. The time complexity for this line of code over here will depend number of the adjacent unvisited vertices. So that's why the time complexity will be OADJ. So in this case, ADJ is the number of unvisited vertices in this case. Then we are going to update the parent of adjacent vertices to the current vertex. So this one also will take O1 time complexity. Now in this case, if you combine these all complexities over here, it's going to be OE time complexity, where E is the number of edges. Because if you multiply V with the number of adjacent unvisited vertices over here, so this multiplication will give us the number of edges, which is E. So that's why the time complexity will be OE. So I've discussed this case in our previous lectures. So it means that if you multiply the number of nodes with the unvisited adjacent vertices of the nodes, in this case, we are getting the number of edges. So that's why in this case, the time complexity will be OE. Now the space complexity will be OV because in this case, we have to enqueue all nodes to this queue over here. So that's why the space complexity will be OV. Now with this, we have come to the end of this lecture. So in this lecture, we have discussed time and space complexity for breadth-first search in case of single source short path problem. So see you in the next lecture.